We're going to use a little bit of algebra in this section to solve for an unknown. Very, very simple algebra. But what we want to solve for is incomes in one period, the equivalent in another period, in terms of purchasing power. Remember, I said, first off, doesn't matter how much money we have. What we care about is what the money will buy. So, first of all, let me show you where I'm going to get the data here. Consumer Price Index, as well as unemployment rates, are calculated and posted by the Bureau of Labor Statistics, the BLS. That's Bureau of Labor Statistics. And that's at bls.gov. And as we talked about in the last chapter, Simon Kuznets thought the lack of economic data during the Great Depression was a scandal. Well, today, I would say they have definitely corrected for that. In fact, I would bet they have overcorrected it. We're drowning in data now. Drowning. They've got it every which way, inside out, upside down, calculated and presented every possible way. Okay? So, it's easy to get overwhelmed. So, if you go to bls.gov, and across the top, you'll see a menu called Data Tools. Well, no, sorry. You'll see a menu. Well, let me go back and read what it says. Across the top, going left to right, you'll see Home, Subjects, Data Tools, Publications, Economic Releases, Classroom, Beta. Okay. Click on Data Tools. Click on Data Tools, and the first thing you see in the upper right, upper left, the other upper right, the upper left, you'll see BLS Popular Series. And there's the most popular of all the 5 trillion data sets that they've got. And you've got employment, productivity, and price indexes. You click on that first one under price index, and that's called the CPI for all urban consumers. All right, that's what we're working off of. So, let's do one. Let's play with this. I remember back when I was a kid, there was a guy in our neighborhood, older guy, and I don't know why I remember this. I just remember him bragging about his $16,000 salary. Okay, he was pulling down the big bucks, $16,000. Well, that was in 1978, as I recall, or thereabouts. I'm pretty sure it was 1978. 1978. Well, before you think, oh my gosh, 16,000 bucks, that's nothing. That's not a very good annual salary. That's below the poverty rate by far. You'd starve living on that. Well, keep in mind, that's 1978, and prices were lower in 1978 than they are today. So what we want to know, what we want to figure out here is what income today would be necessary to have the same purchasing power that $16,000 had in 1978. So what was the equivalent? What's the equivalent salary in terms of purchasing power today? Well, so what we want to do, of course, is the Consumer Price Index. We're going to use that. So what we're going to do is we're going to take the CPI in 1978, and we want the CPI of 2020, and that ratio is going to have to equal the ratio of, the income in 1978 was $16,000, and this is the unknown. So this ratio, we need to find x such that this ratio equals this ratio. Now all we need is the CPI for 1978, CPI for 2020. And we get that off the data set that we... So in hold it, it's not giving me the years I want. And a storm is coming in, and it's blowing, and it's doing all kinds of stuff. I've got to close the window. Whew, time out. Okay, geez, lightning and everything out there. I'm in my office and looking out over, seeing the clouds come in. Wow. Anyway, getting back to our class here. 1978. Well, it gives the months and everything. Let's say it's picked January 78. The CPI was 62.5. Now, what does that mean? That means prices in 1978 were 62.5% of what they were in the base period. So they were lower in 78 than the base period, whenever the base period was. Okay, well, I'll tell you, the base period is 1982 to 1984. And the reason it's 1982 to 1984 is they didn't have, one of my professors at graduate school was an economist at the BLS, and he said during that time, and it's a funny story, but bottom line is they didn't have the budget to update it. And so it's in 1983. So it's 82 to 84 is 100. Okay, and the CPI today, the latest data point at the time of this recording was September of 2020, 259.918. And that. Okay. So, again, we need to find x such that this ratio equals this ratio. Well, the easiest way to do it. Now, there's a bunch of ways. You can cross multiply if you want, whatever. Okay? But I'm going to just keep it as simple as I can. And let's crank this out. I don't know if you can hear the rain coming down out there, but it's sure coming. 62.5 divided by 259.918 equals 0.24. I'm just going to take it out a couple of places. In fact, I think it's kind of funny. They take this out to 3 places. I mean, come on. That implies a level of accuracy, a preciseness that just doesn't exist, okay? But whatever, right? Okay, so 0.24 equals 16,000 divided by x. Okay, now we got to multiply x by, we need the x. We need the x to be by itself, right? So let's multiply both sides by x. Of course, that cancels out. So we have 0.24x equals 16,000. Divide by both sides by 0.24. That gets our x by itself. Okay. Before we go any further, what does this 0.24 mean? It means that prices in 1978 were only 24% of what they were in the base period. Prices in 1978 were only 0.24%, 24% of what they were in 2020. Okay, so they're about a fourth of what they were in 2020. Or in other words, in 2020, prices were 4 times what they were in 1978. Just take the reciprocal. Okay, so 0.24 divided by 0.24, of course that cancels out. And we've got our answer. So x equals 16,000 divided by 0.24, and that equals 66,539.01. Now, I left this 0.24 in my calculator. Even though it shows 0.24, it went going out. It's in my calculator out to 9 places. If you take the 16,000 and re-enter the 0.24 from scratch, okay, you're going to get a little different number. Just want to say, and that would actually be called a rounding error if you do that. 16,000 divided by 0.24. Actually, in that case, you'd get 666.67. Well, what that tells us is you'd have to make over 66,000 today to have the same purchasing power as 16,000 had in 1978. So that $16,000 salary that we're kind of laughing at a little bit earlier, that, wow, what's he bragging about that for? And I mean, this is full-time career employment. As college grad, you know, he got recruited by this company and, you know, all that. So, I mean, this was, well, not so bad for a starting salary for a college graduate, you know, 22-year-old guy. So that's the adjustment you have to make. And if you want to, you know, your parents, no doubt, okay, no doubt. Well, when I was your age, I used to pick strawberries for a nickel an hour, you know, that kind of thing. So whatever it is that they're telling you, you can go in here and plug it in. And now there are websites that do this. Sure, cost of living calculators. You just Google, but this is how it's done. And this is what you'll need to do to get, you know, a correct answer. Is you do it this way. Okay, let's do another one. And this one leads us into the next chapter, actually. Back in 1914, I believe it was 1914, Henry Ford paid his workers double what they could get elsewhere. And he did this, and we're going to talk about this later on in the course, but he did it for a number of reasons, but the bottom line is he wanted to make sure he got the best employees. That's one of the reasons he was willing to do that. What was double the going rate? $5 a day. 1914, Henry Ford paid twice the going rate. He was paying $5 a day. Okay, again, before you say, "Oh my gosh, where was the government?" I mean, where? Holy smokes, those guys were being exploited. Well, let's find out using the CPI. Okay, again, the CPI with its shortcomings, of course, but that's the best we can do. Let's find out what $5 a day in 1914 is today. In other words, what salary today would buy the same, have the same purchasing power as $5 a day in 1914? Now, okay, now, as you know, one of the weaknesses in the CPI is it doesn't consider cost savings from new technology. Has there been a boatload or 5 or 10 boatloads of new technology since 1914? Yeah, it certainly has been. So, be that as it may, okay, let's use the CPI to calculate this. Okay, so CPI in 1914 over the CPI in 2020. Now, what is that? CPI in 1914, well, in January of 1914, it was 10. Meaning, in 1914, prices were 10% of what they were in the base period. Okay, so a tenth of the level of prices in of that of the base period. And today, well, has it changed to 59.918. So, and the income in 1914 was $5. So we want to know what income today is equal to the purchasing power $5 had in 1914. So this ratio, we have to find x such that this ratio equals this ratio. And again, it doesn't matter. In fact, let me do it. It doesn't matter which is on top, but I'm going to do it just to show you. I could have done it this way. Doesn't matter. 1914. And CPI in 2020, 259.918. And 10. And income was 16. Or excuse me, I'm thinking back of the other problem. Income was $5 a day in 1914, and X is what we're solving for. Okay, well, again, you can cross multiply if you want. If you don't even know what that is, whatever. Let's take this ratio and then equate it to that, and then we'll solve for X. So here we go. And I get 25.99. That equals X over 5. Okay, get the X by itself. Well, let's multiply both sides by 5. Of course, that cancels out. And multiply that by 5. And that gives us 129.96. Equal X. There we go. So $5 a day in 1914 is equivalent to $129.96 today, a day. So let's expand that out per year. Well, let's see. Let's find out. Let's go for per week. So times 5 days in a week. So that's 649.80 per week, and about 52 about 52 weeks in a year. Well, let's just go for a full year. 52 weeks in a year times 52 equals 33,789.34. So, if you make $33,789, you're making the same income in terms of purchasing power that an auto worker made in 1914. Now, here's the tie-in to the next chapter on productivity. Do auto workers make more than $33,000 a year? Yes, they make quite a bit more than $33,000 a year. These are highly skilled workers. Lots of capital, okay? Lots of human capital there. And lots of technology, okay? Lots of productivity. How come they're not just making $33,000? Well, $33,000 would be staying even with inflation. Are workers more skilled and more productive in 2020 than they were in 1914? Most certainly, yes. Lots more human capital needed, lots more technology available to them. Okay, and we're going to talk more about this, a lot about this actually in the next chapter. So why do workers in the auto industry make more than $33,000? Because they're more productive. That's it, period. They're more productive. Now, why are they more productive? Again, lots more technology involved, lots more human capital involved. They're more productive. Those are two of the biggest features, characteristics of productivity. The determinants of productivity involve human capital and technology and other things too. Okay, that's the next chapter. So in this chapter, it's just about converting one period to another, and that's all you do. It's pretty easy, really. You just got to make sure you get it set up right. Okay, get it set up, get the numbers right, and then just solve for the unknown. Just basic algebra, manipulate the numbers. The first law of algebra, if you do it to one side, here's a basic algebra lesson, or a little review. If you do it to one side, do it to the other side. As long as you do the same thing to both sides, you're not going to make a mistake. Now, you may not necessarily solve it the most efficient way, but you're not going to make a mistake. Okay, that's it for using the CPI to calculate numbers in different periods.